Hi, I'm Kuri Mordim. I am a electronics, technician. Or I am an electronics technician. I just don't have it as a job currently, but I'm getting another job as a technician in the future. I have 4 years of professional experience, and I have 10 years of hobbyist experience, and I am AC and DC certified. Um, so yeah, I have a little bit of experience under my belt. That's for sure. And today we're going to be going over some of the basics of transistors. Does anyone here already know what a transistor is, or does anyone here think that they can guess at what a transistor does and what it is? Nobody? Alrighty. And to be fair, I mean, you don't typically get to just immediately know what a transistor is if you've never really done electronics before. So that's completely understandable because, yeah, that's a little confusing if you're new to this. So, with the help of ElectroBOOM, I am going to be introducing you to the concept of transistor. Okay, so that was a little bit of a longer one, but I mean, it was actually a pretty concise, at least in my opinion, a pretty concise explanation of BJT transistors. In my electronics class, whenever we had to learn about transistors, it took us like 5 classes to get through it, and I was sitting through every single one sleeping. So, ooh man. It's not a very easy electronics in general is just not really a very easy thing to teach in a very short, concise manner. You have to understand a pretty good chunk of concepts at first, and that is, of course, why we started out with something like Ohm's law. Now, anyway, there's a couple of main things that we're mostly going to be focusing on. We don't really have to focus too much on how transistors can amplify AC and whatnot because we've not even gotten close to touching AC yet. And we have not learned about diodes yet. I just decided to do a class on transistors because I have been working with one that has been infuriating me for the past 3 days that cost $4 and it keeps exploding. That's not the point of the class right now. The point of the class is to understand how they work. So, let me grab my pen here. This right here is a symbol for an NPN transistor. So, as seen in the video, you have your base here, your collector here, and your emitter here. And here's a pretty good example of how we would use it to just turn on and off a load like a switch. Think of transistors as a sort of, kind of like how ElectroBOOM said, an electrically controlled resistor, or a way that I like to think of it is as an electrically controlled switch. So we have a 5-volt signal coming in, and here's a push button here going into... Did somebody want to say something? Okay. So we have our 5-volt signal here going into a push button, which goes into the base of the transistor. Now, you may notice this resistor right here, and you may wonder what this is doing here. This is called a bias resistor. So basically, this biases the transistor either on or off, depending on what you want. So if you want the transistor to be off by default whenever there is no signal going into it, you will bias it to ground or to the negative voltage rail, whichever one is applicable to your situation. And the transistor will then be off until you put a signal into the base. You can do it the other way around as well. You can have it biased on until a signal goes into the base that would, in the case of a positively biased transistor, be a negative signal. So if I press this button, let's see, the current or the signal from the 5-volt input signal here is going to go through, it's going to turn on the transistor, and our load will be able to turn on through 12 volts. We can use a smaller voltage and current to control a larger voltage and current. So, what happens when I push this button? Remember, use the button to answer. Lucas?
Turn on?
Exactly. The light will turn on because the signal is able to make it through and turn on the transistor, which will allow current to flow through. Now, one of the main things to remember for NPN transistors is that they use a positive signal to turn on. So that means the signal has to be above the emitter voltage, which is usually 0 in the case of NPN transistors, because usually you have these connected straight to ground. So your base voltage must be higher than your emitter voltage in order for it to turn on. Now, if we move to a PNP transistor, as ElectroBOOM said, it functions in the same way as a NPN transistor, except in reverse. So instead of using a positive signal to turn on the transistor, we use a negative signal to turn on the transistor. And technically, you can also use a 0-volt signal as well. But generally speaking, you typically use actual negative voltage on a PNP transistor. Now, as you can see here, I have the transistor biased on via a 5-volt input here. This means the transistor by default is going to be what? Can anyone tell me what state this transistor is going to be in? And remember, the PNP uses a negative signal to turn on. It's effectively the reverse of an NPN transistor. So who here can tell me what state this transistor is going to be in when power is applied? Lucas?
It's gonna be off because it has a positive voltage on it.
Exactly. The transistor is going to be biased off by default. Now, who here can tell me what's going to happen whenever I press this button that shorts the base to ground? Oh, Lucas?
Same as the other one. The current will flow from the emitter to the base, and there's gonna be a little current from the emitter to the base, and it's gonna turn on the lamp. Wait.
You're close. You're close.
It's not gonna turn on the lamp.
See, do you see what the lamp is right here at the collector? So you have your voltage input, your supply voltage, your 12 volts that you're going to use to drive your lamp going into the emitter. Right. Mm-hmm. And whenever you press this button,
current's gonna flow to the ground.
And thus allowing this transistor to turn on, and then current is going to flow through from emitter to collector and turn on the lamp. Now, you can actually combine both of these transistors to create an amplifier. And you can actually use them in conjunction with one another to create logic circuits, which we will be getting into later. There's a whole plethora of applications that transistors are used in. As a matter of fact, your computer currently has trillions of transistors inside of it, particularly in the CPU. So does your graphics card. Your graphics card is made up of billions, if not trillions, of transistors. And those transistors are what are currently allowing you to play this game right now. Transistors serve an extremely integral part in electronics. And it mostly comes down to their switching capabilities because they're extremely fast in terms of switching speed. Especially once you get into the more higher speed transistors that are specifically meant for high speed signal switching, and things like MOSFETs as well, which we will be discussing probably next lesson. But there's so many different types of transistors, and all of them have so many different uses. And they are all very important. They play an integral part in our everyday lives. All right. So, if everyone could grab a copy of this whiteboard here, I'm going to challenge you guys, this whiteboard here, I'm going to challenge you guys to complete this circuit to make it work. Now, what I want you to do is I want you to make it so that whenever you press the button, the transistor will turn the lamp on. I'll be writing the solution. And as I'm writing the solution, you guys should, work on finishing it. And then as soon as I'm done writing the solution, I'll come around and I'll check your guys' work. I did not place these components in very good locations. That's funny. Morning. That is definitely a way to do it. That is also a way to do it. Yes, a very interesting way. A way that I have actually used. But technically, you're not supposed to use an NPN transistor this way. I'll explain in a second. But I have used NPN transistors like this before. They get a little goofy when you do that. Charsmere, you good?
Yeah, I'm just still so then the stream can see it. I tried an attempt at it. I don't know if it's correct or not, but I tried an attempt at it.
Yeah, it's the same deal here as with FEP. It's certainly a way to do it, but it's not a great way to do it. And I will get around to explaining why. because,
Okay.
I mean, it works, but it's not the way that NPNs are intended to be used in a circuit.
Yeah.
And yeah, this one is absolutely correct. All right. Okay, everyone. So your circuits should look a little something like this. So as we can see here, we have our 5-volt signal going in. We have a push button here that goes into the base of the transistor. We have the collector here connected to one side of the lamp and the 12 volts connected to the other. And then the emitter goes down to ground. Now, I will say I have seen there are a couple of instances here where people are connecting the, ooh. Oh, what happened there? Hold up. I have seen a couple of instances here where people are connecting the 12 volts to the collector of the NPN here and connecting the emitter to the lamp and then to ground. And yes, this does technically work. However, NPN transistors are meant to switch the load at the collector rather than the emitter. It's the other way around with the PNP transistors. As you can see here, they are meant to switch a load on the collector, but not the... Well, technically this would be considered the emitter, but conventionally we call the emitter the collector and the collector the emitter because it's reversed. But conventionally speaking here, it's kind of the same deal. So whenever you connect your load to the emitter, what ends up happening is that because not only does it draw current, but it's also connected directly to ground, essentially through the load, you get some weird logic things that'll happen. I personally have had instances where my transistors will just not really work great in terms of like working as a switch, because I'll have them like biased and everything. I'll have them biased. Oh, I'll just bias it to 5 volts and it'll work perfectly. And no, it doesn't, because my load is always on. So that is why we actually switch it via the collector. Because if we switch it on the emitter side, then there's going to be current constantly flowing through the transistor and it'll go through the load. And even if you bias it to negative voltage, it can still cause some weird side effects to happen and really mess with your logic. This is why, by rule of thumb, we generally don't switch on the emitter side. We generally switch on the collector side. This is actually why. This is why conventionally we draw PNP transistors with the collector down here and the emitter up here, because you don't connect your load to the emitter side. You connect it to the collector side. And in this case, since the PNP is essentially the reverse of an NPN, the collector is down here and the emitter is up there. And I don't know, me personally, I just think that's really confusing, but it's how it's done conventionally. So I'm not gonna change the rules and try to be quirky about it. So the next thing I want you guys to do is I want you guys to design your own circuit using a PNP transistor. And that PNP transistor will turn on an NPN transistor. So you can actually grab a whiteboard right here. Just click on it. Now, just keep in mind it will be reversed, so you will have to flip it towards you. Like so. But I want the circuit that you design to be designed in such a way that a PNP transistor drives an NPN transistor, which is then driving a light. Now, I'm not giving you a template for this. I want to see if you guys are able to draw up your own schematic. This is good practice for seeing if you guys can remember the symbols that I have given you and apply them. I've been going in circles a lot. You are completely free to reference the material on the... You're completely free to reference the material that is on the board or that is up here, because these are indeed relevant and they can definitely help you out in understanding how schematics are drawn if you still have a hard time with it. If you need any help at any point, please ring this button right here and I will be there to help you. Alrighty. While you guys are doing that, I'm going to go ahead and start drawing up the solution. And whenever I'm done, I will come around and check your work. Yes, correct. Alrighty. Let's see what you guys got.
I don't have anything quite yet because I didn't really quite understand how to make my own schematic.
Remember, I did say that if you need any help, you can always ask for it. I'm here to help.
I'm trying to figure it out right now.
Yeah, that works. That's a good basic interpretation. I can't get over it, man. We're grounding to the clouds. I can't get over that. That's funny. I will say, though, this is to the supply voltage, right?
Which one?
This here, is this going to supply voltage or is this your ground?
That's ground.
Okay, so I think you've got.
I'm also missing a switch, which I just know, so a button.
Yeah, you're missing a button to control this transistor, and additionally, remember this is a PNP transistor. This operates in essentially the reverse as an NPN transistor. So we don't use a positive voltage unless we're biasing it off. So whenever we want to switch it, we're gonna switch it where?
To ground.
Exactly. And this right here just means that this is essentially just shorted to ground. So this won't do anything. This can still be connected to, let's see. This can still be connected to supply voltage.
What if I put a button between, oops, shit. This up here, oh, I didn't turn on. This and ground. Between the collector and ground, I put a button. Would that work?
Not for. I don't think that would work. At least not for the specific. Not for the specific situation. Because what I want is I want the signal via a button to control the PNP transistor, which will then invert the output and send it to the the PNP transistor will invert the output and then send it to the NPN transistor, which will turn on or off based on that inverted output.
So also put 5 volts on the collector of the PNP. Wait, collector or emitter? Give me a sec. Ah, emitter.
No. Because, see, what we're doing is with the NPN transistor, we're switching from the collector. So our load goes through the collector, that's right. And then the emitter goes down to ground, which is also correct. And then we have the collector of the PNP transistor going to the base of the NPN, which is also correct. However, we still need a signal voltage here.
Yeah, I get it.
So, and on top of that, this transistor, if it's connected straight to signal voltage, this transistor, since it's a PNP and this is a positive voltage, this transistor will always be
On.
Other way around.
Off.
Boom. It'll be off because this is a PNP transistor. It works in the opposite way of an NPN. If we connected the NPN straight to the 5 volts, it would always be
on.
Correct. Because these two are essentially opposites of one another in terms of what they need to turn on and off. So what you'll want to do is you have the right idea, kinda, with connecting the 5 volts to the base, because that does give you a chance to bias this transistor off. However, it's connected straight to it. There's nothing limiting the current. So if there's nothing to limit the current, then this, your collector is always going to be higher than your it's always going to be higher than your base, and your base has to be lower than your collector voltage.
So put a resistor in there.
We have to have a resistor in there to limit the current. That way, whenever you press the button, not only does it not instantly short this 5 volts to ground and blow everything up in a blaze of glory, but it'll also make sure that it's properly biasing the transistor in such a way that it can still be triggered by shorting the base to ground.
Okay, I try something.
All right. And remember, you still have to have a positive voltage going into the emitter. That way it has a signal to switch. All right, let's see what we got going on here. 12 volts goes in. Yep, switches via collector. Collector of the PNP goes to the base of the NPN. Yep. We have this biased high in order to have it turn off, and then we have that's correct.
Yay.
Good job. You need some help, Charsmere? Probably on Discord. I think there's a slight misunderstanding. So you'll want this to be connected straight to your 5 volt signal, because this here is the signal that you're switching. Now, you'll want this push button to actually be at the base of the transistor, and you'll want this shunting the base to ground.
Or when there's Okay.
Because see, if we have it just set up like this, then it's not really gonna do anything, because it's always gonna be turned off, because this resistor is biasing this off, and there's nothing to pull it down low, so it won't turn on again.
Fair. Yeah, good point.
I'll leave you with that information and not completely spoil it. But see if you can use that information to your advantage. Something tells me you've done electronics before.
A little bit, yes.
Makes sense. That makes sense.
But it's been quite a time.
That's fair. Hopefully this is a pretty good refresher for you. Also, good lord, I love the Derg. That's adorable. Considering you say that you're pretty rusty, but like honestly, that's really good. Considering how I'm guessing since it's been a while, I'm guessing it's been a few years since you've actually done anything with this.
Yeah, but I always think in terms of like voltages, like, oh yeah, there's like 5 volts here, 5 volts over there, and then like increases the voltage, and that's what switches the transistor on or off. I understand logic very well, so that makes it easier. Like,
yeah,
figure everything out.
this is essentially just an inverter. Essentially just a NOT gate.
Oh, not.
Is it?
That or it's just a complicated buffer.
Yeah.
I think it's just an overcomplicated buffer.
If you have knots.
Right. I didn't. I would have had to wire it slightly differently to make it a NOT. Eh, that's fine. It's a good kind of a good refresher for me too, because I don't really use PNP transistors that much. I mostly deal with NPN stuff. I've not had to deal with PNP in a while.
Are they less?
I've
common?
not had.
Are they less common?
See, for what I'm dealing with, yeah, they're not really the main thing that is used in stuff that I deal with. Like I deal with like high voltage stuff. So I deal with things like ZVS drivers, which usually use NPN transistors. I deal with IGBTs, usually N channel MOSFETs, things like that. Yeah, I've only like just recently started trying to get back into like using PNP as complementary components for NPNs for things like amplifiers. Like I don't really build amplifiers. I built a tube amplifier and that was about it. I've not had to make a proper signal amplifier, so. Alrighty. Let us see. Oh, you were close. You were very close, but you were missing one thing. You're missing one thing. That's it. See if you can guess what you're missing. It's actually pretty simple, though. Because this transistor turns off whenever the base is pulled down to ground. But it's only currently being pulled up. So
Brain or braining. Yeah, but where? Huh?
here. Oh. Right.
That looks illegal to me.
Probably because we have the 5 volts going through a resistor to ground.
Yeah.
But here's the thing. This resistor is typically a very high value resistor. So somewhere around 10 kilo ohms-ish. So you're not going to have a lot of current just getting wasted down to ground. You don't have a lot of current getting wasted. Full stop.
So the PNP just needs to be pulled down via ground.
Mm-hmm. See, look. This button here, whenever you press it, there's going to be a little bit of current flow going from the emitter to the base, and it'll go through ground. Thus, it'll create a negative voltage path and pull electrons down to ground. And this will turn it on and allow a much greater current flow from the emitter to the collector here, which means the signal is going to go right into the base of your NPN transistor, which will turn it on. All right, guys. So your schematics should look a little something like this. Let me just move these out the way. Do you know the way? So what we have going on here is we have our 5 volts. It's going down through a resistor to bias Q1, which is our PNP transistor, off. So it's turned off most of the time. And so we also have the 5 volts going into the emitter so that whenever we switch this on, we have a 5 volt signal going to the base of Q2, which is an NPN transistor. Now, whenever we press this button, current is going to flow through Q1, which will then positively biased. It'll turn Q2 on, which is normally positively biased off, and thus current will flow through our load here, which is a lamp in this case. It'll flow through the transistor and down to ground. Now, we can actually swap a component, or we can swap a couple of wires in this, or a component rather, in this circuit. And by swapping said component, we can actually turn this into a type of logic called an inverter. And what an inverter does is, actually, I'm gonna see if I can get someone to guess what an inverter does. It's a as the name implies sort of thing. Does anyone want to tell me what they think an inverter does? Lucas.
It inverts?
Exactly. It inverts a signal. So I'm going to draw up a little something here called a logic table. So what an inverter does is if we have, actually, I can just go ahead and draw it right here. If we have our input and our output, we can create a table here. When our input is on, our output here is going to be off. Now, based on what we have here, and based on the name of this device, what do you think is going to happen if we have the input off? Who here wants to have a guess? Don't be shy. SCP?
It turns on.
Correct. So if our input is off, our output is going to be on. Now, with this knowledge, let's see if you guys can guess the one component in this circuit, or the little modification of this circuit that you have to make in order to turn it into an inverter. I'm going to go ahead and start drawing up the solution. I'm going to make a copy of this first, so that way you guys can reference it still. SCP?
Isn't an inverter just everything except Q2? So if you only have the first PNP transistor?
It can be, but I still want you guys to use both transistors just so that you can kind of get an understanding of how they can interact with one another. That, and additionally, you will typically condition the signal using another transistor to make sure your signal is buffered and strong. That way you don't have some weird funkiness going on with your signal. You don't have crosstalk and all of that other fun stuff that can happen. Basically, redundancy. All right. I'm going to be coming around.
Give me a sec.
This work?
So it looks like you're still biasing your PNP transistor off. Now, for an inverter, you will want to bias it on, preferably. Yeah, you'll want to bias your PNP on, preferably. And you'll want to bias your NPN off, preferably.
Mm-hmm.
So basically, just kind of invert what you have going on, and then it should work. What? Yeah, I was about to say. Huh? No, this is funny. I have to say this don't exactly work, but it is funny.
Wait, that would work?
It would work, yes, but it doesn't work right. This is the most inefficient way to get anything done. This is just like at this point, because like, look, this is biased. This is like biased off all the time,
Yeah.
and this push button is here, so it's like, I mean, unless you turned off your 12 volts, it would do nothing.
Isn't the
You might as well just switch straight to it.
Isn't the NPM also off? No, on all the time because it's directly connected to 5 volts.
Yeah, the end is on all the time because it is indeed connected to 5 volts.
I don't think this.
So this here, this is accurate.
Yeah, yeah.
That's funny.
think?
I think. Ooh.
Just back to square one.
Let me double check your connections here. Oh, but it is biased the incorrect way. So basically you flip this bias resistor down here and you have this connected up there.
It's basically with the
While you're doing that, give me just a second.
You said it switch one component becomes inverted, right?
I think I might have misspoke whenever I said that, honestly. You can switch, I think it, well, no. Because technically, you do switch, like, one component from one side to the other. Let me check my old schematic just to make sure.
Oh, this is the same. I know.
Oh, yeah. So I was right. You switch, well, it's not, it's technically two components, but you switch one component with another, and that gives you an inverter. So basically, we just switch R1 and the push button, and it gives us an inverter.
Ah. See.
I'm gonna have to check something. Okay. You put it there. People were pinging me on Discord. Yep, that's correct.
Really, I think the easiest solution would just switch the button from a normal open to closed. There you go.
I mean, you could technically do that, but what if we don't have a normally closed button? What if we just have a normally open? Very, very close. However, there's a little weensy little problem. What's gonna happen whenever you press this button?
Oh, we short to ground. Oh,
You're shorting your supply to ground.
wait, no, that was
and then your supply explodes, and then you're left with fire.
The idea I had was by default that PNP is now grounded, which would mean I put the resistor in the wrong place.
Yeah, you gotta move this here.
Yeah. Isn't the NPM transistor back here irrelevant? The only purpose it serves is to have the 12 volts turn on. So we turn 5 volts into 12.
Which transistor? Sorry.
This PNP.
This one?
The first one. No, the left one.
Oh, this one?
That's PNP, right?
Yes, this one is P and this one is NPN.
Yeah, the PNP, that's the actual inverter. And the
Yes.
NPN only
The
turns on
NPN
the
is
light.
acting. Yeah, the NPN is acting as what we call the buffer. So it takes the signal output and it buffers it, which conditions it so that not only is this the transistor that switches the load, but also that signal is actually good and strong, so that we're not dealing with crosstalk between the 5 volts and the 12 volts.
Okay.
This is what's usually done in logic circuits.
Oh my bad.
Huh?
I think we should get some kind of simulator in here so you can connect.
I would love something that I would love is an is like something like LT Spice, some sort of like Spice simulator. That'd be so cool. That, or maybe like an actual breadboard thing you could like put components down on and like make your circuits and stuff. Or like a thing where you could draw your circuits in the air and they would actually work. God, that'd be so cool.
Very complicated.
Since you seem to be excelling so far, I'm gonna have you do a special assignment.
Oh no.
Yeah. I'm gonna challenge you to make a NAND gate using only transistors.
Oh boy.
I saw this.
I'm excited.
Oh, and don't worry, it doesn't have to be an XNAND, so you're not dealing with the XNAND stuff, just a regular NAND circuit.
What's an accent?
XNAND is exclusive NAND, so you know XOR, XNOR, etc. Yeah, XNAND is the exclusive NAND. So basically, you know how in an OR circuit, you have like this or that, and then I think there's one of them where when both inputs are active, it'll pull out or it'll give out a true output. An exclusive OR negates that. So it's only if this or that. If it's both at the same time, it puts out false.
Mm-hmm.
That's exclusive OR. It's kind of the same deal with like XAND, XNAND, XNOR. It's the same deal. So you're just dealing with a regular NAND circuit. Don't worry about the exclusive bit. I'm not worried about that right now because that exclusive NAND is complicated. Yep, bingo. This is correcto mundo. Good job. All right, so your circuits should look a little something along the lines of this. Oh, there's no way that I can make it big. I'll go ahead and put it up here. So we have our 5 volts and our 12 volts. We have our load here. In this case, I just drew up a lighting diode. Let's just say a 12 volt LED. It's a light. It's a light. That's all that's important about it. This is our load, and it is a light. Now, we have our 5 volts going into Q1, but Q1 is biased on. So this transistor is on until we press the button, and in which case it'll turn off. And then the output of that goes to our NPN transistor's base, which will turn on or off our NPN transistor depending on the output of the PNP transistor. So whenever the button is not pressed and there is no input, the load is turned on. But whenever you press the button and you have an active input, output here, which is our load, it turns off. This is a very simple inverter. This inverts the input signal that we give it. So when you are giving it a signal by pressing the button, your output turns off. But when you let go and are no longer giving it a signal, our output turns on. Hey, by the way, Charismare?
Yeah, what's up?
If you would like some private lessons on things like schematic drawing, because I see you might be struggling a little bit with understanding how to draw schematics. If you want like lessons with that, so, like help tutor you and get you better familiar with schematic drawing, I can do that.
Yeah, I appreciate that. I'll let you know when I want to look into that.
Okay. Awesome. Yeah, just shoot me a DM on like Discord or something, or like whatever, depending on are you in the Metaverse Academia server?
Yeah, I'm streaming to it right now.
Oh, cool. Well, you should be able to just shoot me a DM at any time, and you can set up a appointment, and we can get all of that scheduled, and then I can give you a private tutoring.
Yeah, sounds good. Sounds good.
Alrighty. What's up? Yeah, sure. All right. Alrighty. So, all in all, this is just a pretty basic understanding of the usage of BJT transistors. You guys are actually doing really well so far. Our next class is likely going to be focusing on MOSFETs, which is like a slightly more advanced transistor. But in the meantime, hopefully this what we have learned today will give you a pretty good basic understanding of how transistors work. The two basic transistors that you will see anywhere you go, really, and pretty much the importance of them. So thank you guys so much for coming. I much appreciate it, and I look forward to teaching you again in the future.